Alright, so now we're going to use factoring to make predictions with quadratic models. That means that we're going to use factoring to solve some word problems. Alright, so take just a second to read through this problem and just understand that sometimes the first time you read through something it doesn't really make a whole lot of sense. Sometimes the second time it doesn't. Sometimes it takes a couple of times, 2 or 3, 4 times to read through something before it starts to make sense. Alright, so it says here's our table, and we have a model of the situation. That model means this is our equation that we're going to use, okay? Just know that E is our enrollment, and T is time, which is in weeks, since, what did it say? It said since July 2nd. Alright, so we're going to use this equation right here. Now let's read what they're asking us to do. Alright, we're not going to do step number 1 because we're not going to use graphing calculators in here. So on part number 2 it says we want to estimate when the enrollment was 19 students. So I'm going to put 19 in for E and I'm going to solve this thing. So I'm going to go back here and I'm going to scoot this up. And I'm going to put 19 is equal to t squared minus 1/3 t plus 11. Alright, so now I want everything equal to 0, so I'm going to subtract 19 from both sides. Notice how I put the like term underneath its like term. Now what I want to do is I want to get rid of that fraction. So I'm going to multiply everything by 3. Where did I get 3 from? Well, it's the denominator. That's how I get rid of it. So I'm going to multiply 3 times every single term. So I get 0 is equal to 3t squared minus t minus 24. So now I'm going to multiply 3 times negative 24, and off to the side I'm going to write negative 72 because I get negative 72 whenever I multiply 3 times negative 24. I want factors of negative 72 that add up to be negative 1. That's our middle term. And those are going to be negative 9 and positive 8. So I'm going to rewrite the middle term using negative 9 and positive 8. And so now I'm going to factor using grouping. Can factor out a 3t there, so I'm left with 3, I'm sorry, that is wrong. I'm left with t minus 3. I'm going to factor out an 8 here, so I'm left with t minus 3. I'm going to move this up here. So I've got t minus 3 and 3t plus 8 is equal to 0. Now I'm going to take each one of these parentheses and I'm going to set them equal to 0 and I'm going to solve. I'm going to add 3 to both sides here. I get that t is equal to 3. I'm going to subtract 8 and divide by 3. And I get that t is equal to negative 8/3. Okay, we did a lot of good math here. But sometimes you come up with solutions that just don't make sense. And whenever we're dealing with time, most of the time, negative answers do not make sense. And in this case, that is absolutely true. So this answer right here does not make sense. Even though we did good math, everything was great, it still doesn't make sense because we are talking about time since July 2nd. We can't go back 2 1/3 weeks or 2.5 weeks or whatever. Okay, so we're only looking for this one. So 3 weeks after July 2nd, enrollment was 19 students. Okay, so if you take a look, where would 19 fit in this table? It would fit right here. Notice how that 3 is missing. So it does fit in the right spot of this table. So I do feel pretty good about this answer right here. Alright, so now we're not going to do number 3 here. It says here the maximum enrollment for the class is 35 students. Estimate the number of students who were waitlisted as of the first day of class, which was August 13th, which was 6 weeks after July 2nd. Okay, so they give us a lot of information here, but really the most important thing that we need in this problem is we need the 6 weeks. And so which one do we put that in for? Do we put that in for enrollment, E, or T for time? Well, weeks is time, so I'm going to put 6 in where I see T. Okay, so I'm going to put E is equal to 6 squared minus 1/3 times 6 plus 11. So I've got 36 minus 2 plus 11. So I've got 36 minus 2 is 34. 34 plus 11 is 45. Now what does that mean? So at 6 weeks, the enrollment, was 45 students. Well, let's go over here and let's read this question again. The maximum enrollment for the class is 35 students. They want us to estimate the number of students who were waitlisted as of the first day of class. So that's what we found. 45 students enrolled. 35 is the max. So 45 minus 35, which is 10. This right here is what we're looking for. So we have 10 wait-listed students. That's what we're looking for right there. Alright, so now we're going to make estimates again. So a batter hits a baseball into the air. The height h, that's what we're dealing with, h here, and we're also dealing with t. So the height h in feet of the baseball at t seconds after the ball is hit is given by this equation here. When is the baseball at a height of 84 feet? So that's my height. I'm going to put 84 in for h. So I've got 84 is equal to negative 16t squared plus 96t plus 4. So I'm going to get this equal to 0, so I'm going to subtract 84 from both sides. Okay, and what I've learned about these height problems is that a lot of times I can factor out that negative 16, which makes my life a lot easier. So whenever I factor out the negative 16, I get t squared minus, what is that? Okay, so minus, let's look at 60, and then plus 5. So now I want factors of 5 that add up to be negative 6. So it looks like that's going to wind up being negative 1 and negative 5, right? Okay, so this thing factors to be now I'm going to take each of these sets of parentheses and set them equal to 0. Now, negative 16 can never equal 0. So that's just something we're not even going to worry about. So negative 16 does not equal 0. So I'm going to do t minus 1 equals 0 and t minus 5 equals 0. Alright, I get 2 answers here. Think about that for just a second. So the question says, when is the baseball at a height of 84 feet? So when somebody throws a baseball, the graph of it looks something like this. So actually, this ball is at 84 feet twice, when it goes up and then when it comes down. So number 1 actually has 2 answers. It has 1 second and 5 seconds. So those are my 2 answers for number 1. Question number 2 says, when is the baseball at a height of 148 feet? Alright, so let me erase this and then we'll work on that one. Okay, so I'm going to put 148 in for h in my equation. So 148 is equal to negative 16 t squared plus 96t plus 4. And I'm going to subtract 148 from both sides. 0 is equal to negative 16 t squared plus 96t minus 144. Alright, now this is what I'm going to factor, but luckily the negative 16 factors out again. So I've got 0 is equal to negative 16. I'm factoring out the negative 16. T squared, let's see here, that's minus 6t. And I get 9 there. Okay, so this thing factors to be and so check this out. I only get one of these answers because it can only happen at 3 seconds one time. So t is equal to 3 seconds. Whenever you get 2 of the same answer, that's your vertex. So, well, yeah, it is a vertex. In this case, it's our only vertex. So 148 happens to be at 3 seconds. Why can't I remember the C there? 3 seconds, 148 feet, and this happens to also be our vertex. So that means that this thing, the height of the ball, that's the highest that it will ever go. So that helps us with question number 3. It says, when is the baseball at a height of 150 feet? Well, if 148 feet is our highest point, it will never be at 150 feet. So a good one-word answer for that would be never. Alright, so let's look at this problem using the area of a rectangular object. So a rectangular garden has an area of 40 square feet. So length times width is 40 square feet. If the length is 3 more than the width, find the dimensions of the garden. So I'm going to multiply W times 3 plus W, and I know that that equals 40. So I can distribute. And now I'm going to pull everything over to one side, and I'm going to write it in standard form. So now I'm going to factor this. I want factors of negative 40 that add up to be 3. They are W plus 8 and W minus 5. Take each of those and set them equal to 0 and solve. Alright, so now take a look at these 2 answers. For one thing, I can't have 2 widths. It's not possible. It's a rectangle, for heaven's sakes. So I can't have 2 widths. So think about which one of these answers doesn't make any sense. Well, the negative one doesn't make any sense because we can't have a negative width. So if my width here is 5 and my length is 3 more than that, that means my length has to be 8. Don't forget your feet. All right, so that's it for this section. If you need any help, let me know.